Welcome to video on skill number 63. I can graph and recognize inverses of relations, functions, and find inverses of functions. We'll begin our notes on page 63A. And today we're going to be learning about the inverse of a function. Basically, an inverse performs the opposite of the function, or undoes it. So with a function, what we have is we might take an input and put it into our function, and it spits out an output. And in this case, our function is x plus 6. So if we put 3 into the function, it spits out 9. Well, the inverse function would be take that 9 and put it into the inverse to get 3. So what is the inverse that allows us to take a 9 to arrive at a 3? And finding the inverse of a function is actually a relatively easy process to do most of the time, particularly on linear functions. So step 1, we're going to have our function and we let the function be equal to y. So our f of x becomes y, and we have y equals 2x minus 4. And I'm just using this function as an example. The second step is we switch the x with a y. So our x becomes a y and our y becomes an x. So now we have x equals 2y minus 4. And then finally we solve for y. So in order to solve this function, or this expression for y, first we add 4 to both sides, and then we divide both sides by 2. And this allows us to find the inverse. So the notation we use for inverse is f to the negative 1 of x. And this does not mean raise the rule to the negative 1 power. It's the notation we use for inverse. It should be noted that not all functions have inverses, and we'll learn some rules for how to identify whether a function has an inverse later on in this unit. So we can use inverses on both relations and functions. We typically see relations as a series of points or data that doesn't necessarily behave like a function. To graph the inverse of the relation, just reflect each point across the line y equals x. This is equivalent to switching the x and y values in each ordered pair. So below I have a relation, and if I wanted to graph that relation, I've got my axis, and then I've got a point at 0, 1. I've got a point at, that's 0, 2. I've got a point at 1, 4. I've got a point at 2, 5, and one at 3, 5.5. So it looks like I've got some sort of curve going on like this. If I wanted to graph the inverse of that, what I would do is I would switch my x and y. So my x and y coordinates switch place. So my 0, 2 becomes 2, 0. And the 1, 4 becomes 4, 1. And we can graph the inverse, so we have a point at 2, 0. We have a point at 4, 1. We have a point at 5, 2. And a point at 5.5, 3. And so it looks something like this. It appears as though the inverse is a mirror image across y equals x. And it should be. If we are graphing these and we see that it does not look like a reflection over that line, then we perhaps made a mistake in the process. If we wanted to list the domain and range of each set for our relation, our domain goes from 0 out to 5.5 on the x. 0 out to 3 on the x. So 0, 1, 2, 3. So it goes out to 3 on the x, and our range is from 2 to 5.5. If we wanted to find the domain and range of our relation, or the inverse of our relation, we just switch these two. So the domain becomes from 2 to 5.5, and the range goes from 0 to 3. At the bottom of the page, I've put in a second example for finding the inverse of a function. So in the first step, we've got the function. Oops. The function is right here, and we replace y for f of x. And then to find the inverse, what we're going to do is we'll switch x with y. So x and y switch places. And then in the next step, we solve for y. So let's subtract 4 from both sides, and then we'll multiply both sides by 4, and we get 4x minus 16. So the inverse is f inverse of x equals 4x minus 16. Finally, on page 63C, I give an example of how inverse functions are used within the context of a story problem. Example 3. Archaeologists use models for the relationship between height and footprint length to determine the height of a person based on the lengths of the bones they discover. The relationship between height, h of x, in centimeters, and footprint length, x, in centimeters, is given by h of x equals 1.1x plus 143.6. And we want to use this relationship to predict the footprint length for a person who is 170 meters tall. Now notice for our function, what we have here is we input the footprint length into the function and it outputs the height. Well, what we're asking is, if you have the height, what is the footprint length? So what we need to do is find the inverse of this function so that we have the height and we can plug it into the function inverse and get an output of footprint length. So the way we do that is we take our function and put y in for the function, switch our variables y and x, and then solve for y. So to solve this, first we subtract 143.6, and then we're going to divide both sides by 1.1. This gives us our inverse function. From here, we can take the information they gave us and solve. They said our input is 170 meters tall, so we plug that in for x, and we solve the whole equation, and we arrive at 24 centimeters. Which means a person who is 170 centimeters tall likely has about a 24 centimeter length footprint. All right, for skill 63, there's two key concepts, basically the inverse relation and then inverse function. We should be able to graph the inverses, and we should be able to identify the domain and range of the inverses. It should be noted that the inverse relation or the inverse function is basically a mirror over the y equals x line. And domain is usually written in set builder notation, so something to this effect. So if this was our domain of our function, then the domain of our inverse, or rather the range of our inverse, would simply be this with y's in place. As demonstrated here, here's the range of the inverse. We just rewrote it as range rather than domain, and our x's became y's. All right, this concludes the lesson.